Be learning about arithmetic and geometric sequences, starting Miss G and Miss V. Materials you're going to need for this lesson is going to be week 3 from your packet or Google Classroom assignment. On your packets, do remember you need to submit images to your teachers, whether it be through email, text, or Remind. On Google Classroom, you just have to do the assignment and turn it in. You do not need to do both. You choose the one that best fits. Please don't be doing extra work. I mean, if you want to, of course, by all means do it, but you do need to think about the other classes that you need to do assignments for. So one or the other, don't do both. All right, let's go ahead and begin about arithmetic sequence, which is the first topic. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate, which is also known as a common difference. This keyword, common difference or constant rate, makes an arithmetic sequence. You can have numbers lined up, but if they're not increasing or decreasing by the same number, it is not an arithmetic sequence. Notice how the two examples they give you here, one's increasing by 2 every single time and one's decreasing by 4, meaning this is an arithmetic sequence because they have a common difference. Vocabulary words that you will be hearing is sequence. A sequence is the numbers lined up. And terms. Terms is the numbers inside the sequence. So these are the words, the vocabulary words that you're going to be hearing a lot throughout this lesson. Okay, so keep that in mind. Sequence is all the numbers lined up. Terms is individual numbers. So let's go ahead and practice by finding out the pattern, or also known as a common difference. What we are going to do to tackle these problems down is ask ourselves 2 questions. Is it increasing or decreasing? And if so, by how many? So let's take, for example A, 2, 4, 6, 8, 10, 12. If you notice, I'm increasing. And this is kind of simple because you're counting by 2, so meaning I'm increasing by 2. Okay, simple. Moving on. Letter B, 7, 10, 13, and 16. Okay, I know I'm increasing, but let's figure out by how many. To get to 10 from 7, I have to add 3. To get to 13 from 10, I add 3. 16 from 13, I add 3, meaning my common difference is plus 3. Simple. Moving on. Letter C, negative 15 to negative 10 to negative 5 to 0. Okay, I know I'm increasing because I know the negative rules. The bigger the number, the smaller it actually is if it's a negative. So I know I'm increasing. The next thing I need to know is by how many. Well, if I notice from 15 to 10 is a 5 difference and I'm increasing, so it's going to be increasing by 5. So this is known as your common difference because this is a pattern that it has. Now knowing the pattern of each sequence, let's find the next term. How do I do that? By just applying the common difference you find. So I'm either going to add or subtract the pattern we found to the previous term. So for example, letter A, increasing by 2, so I'm going to add 2 to 12 to get the next term, which is 14. And then you do the same thing for every other one. So 16 plus 3, 19, 0 plus 5, 5. These are my next terms in the sequence. Common mistakes. This is something you need to look for. Just because there are numbers lined up like a sequence doesn't necessarily mean they're an arithmetic sequence. The common difference must be constant, meaning it has to be the same for every single term. It can't have a plus 2 and a plus 4 and you think that's a constant because it's by 2. No, it has to be the exact same number. So how do I know? Look for common difference between the consecutive terms. So for example, let's discuss. Example 1, 2, 4, 8, 16. Okay, so I know it's increasing. From 2 to 4, it's increasing by 2, check mark. From 4 to 8, it's increasing, but by 4. So I already know there, that's not an arithmetic sequence because my common difference isn't the same. All right, let's see another example. 48, 45, 42, and 39. So 1, it's decreasing. 2, let's see by how many. From 48 to 45, it increases by 3. I subtract them, it gives me 3. Okay, 45 to 42, also 3. 42 to 39, also 3. So guess what? My common difference for this one is minus 3 or negative 3, meaning this is an arithmetic sequence. So notice the difference, okay? Moving on to recursive formula. This is a formula for the arithmetic sequence to be able to find whatever term they want us to do. So let's say, for example, they only give us 5 terms and they want to know the 1,000,000th term. Obviously, I'm not going to be doing plus 2 1,000,000 times, right? Or however many I need to get to the next one. What I'm going to do is I'm going to take a formula and I'm going to apply that formula to find that term I'm looking for. So nth term of arithmetic sequence is this formula. an equals a1 plus, parentheses, n minus 1 times d. Making the first thing you see in the equation the nth term, the one I'm trying to find. A1 is the first term that I give you in the sequence. Letter N stands for the nth term or the term position they want. So if you notice, the first one and the N is going to be the exact same. One is going to say 8 to the 100th and the other one's going to say 100. And letter D is common difference. Okay, so let's go ahead and try this formula out and see how it is applied for me getting the a gazillionth term, right? All right, so here I have a sequence 75, 87, and 99. So what I'm going to do is I'm going to take these 3 and I'm going to figure out, okay, first, what is my first term? Bam, 75, genius, right? I'm already done. Moving on, what is my common difference? So what I'm going to do is I'm going to take the 3 numbers and I'm going to figure out what is the common difference. So I know it's increasing. How many is it increasing by? You can subtract these 2 numbers and know the difference. And if you notice, for every single one is 12. So my common difference is 12. Okay, I have these 2 things now. We believe in you. Let's take the recursive formula and plug in what we do know. I don't know what AN is because they haven't told me anything about it yet. I don't know what term they're looking for, but I do know A1 and I know the letter D. So I'm going to substitute. I'm going to substitute the 2 things I do know, which is A1 and the letter D. So making this my new equation. So AN equals 75 plus, parentheses, n minus 1 times 12. Okay, next we're going to distribute. When you distribute, you need to be fair. What I mean by fair is I'm going to multiply this 12 with everything inside the parentheses. So common mistakes is we only multiply with one thing. But we need to be fair and give Juanita and Juanito both chocolates because they're both inside the store, right? So once I distribute, which means multiplication, I'm going to multiply 12 times n and 12 times negative 1 to give me my my next step. Okay, so this is what it comes out to be. 12 times n is 12n. 12 times negative 1 is negative 12. The plus 12 came out because this times this is a positive. And the minus 12 came out because this times this gave me a negative. Some of us forget to put signs in the middle, which you can't do that because this is an equation. I need to have signs in the middle. Okay, so next step is to combine like terms. Remember, combining like terms means I'm putting things that look alike together. So there is no other n, so I'm going to leave n by itself. So 12n is by itself, but I know 75 and 12 are numbers. So I'm going to combine those. 75 minus 12 give me 63, a positive 63. Therefore, I put a plus, okay? Don't forget that. This is also known as an explicit formula, or if I want to get fancy, I'm going to put it as a function notation, which I'm going to just put the letter F, okay? Both the same thing, is just one's a function notation, the other one is explicit formula. Okay, so now let's go ahead and use this formula or this equation that we just found to find the 60th term. So I'm going to take the equation I got, which is AN equals 12n plus 63, and I'm going to substitute to find the 60th term. Remember, letter N stands for term. So my term that I want here is number 60. So let's go ahead and substitute. Every time you see a letter N, I'm going to put the number 60. Bam. Okay, I put parentheses 60 because this is understood to be multiplying. So I'm going to put parentheses 60 because this also means multiplication. All right, once I'm done with that, I'm going to calculate, and ta-da! there is my 60th term. So the 60th term of the sequence is going to be 783. Imagine trying to do this all the way with just doing the plus 12, plus 12, plus 12, plus 12, all the way to 60. Forget it. It's going to take you forever. So just figuring out what the equation they're using and substituting